Hello, esteemed colleagues, participants, and guests of this conference. My name is Egon Cholakian, and I am a national security expert, a representative of ALLATRA, and a particle physicist. It is a great honor for me to speak at such a significant event as the 16th Conference of the Parties, taking place today in this magnificent country, Colombia. Today we have gathered here not just as scientists and politicians, but as global citizens who share a common concern for the future of our planet. In recent years, we have witnessed that climate change is progressing much faster than we could have anticipated. This realization is alarming to all rational people, and we cannot remain indifferent to this problem. At this point, many scientists, authors of various theories and models, admit that their predictions were way too optimistic. We must seek not only the factors contributing to this rapid climate change, but also ways to mitigate its pace. Each of us here today has an invaluable role in this vital mission. The fact that current events are outpacing even the most advanced models developed by the world's leading experts prompts us to consider what additional factors might be contributing to such abrupt changes in the climate system. There is substantial evidence that alongside anthropogenic factors, that is to say, the increase in greenhouse gas concentrations in the atmosphere contributed by human beings, we are encountering geodynamic anomalies that previously did not exhibit such strength and scale. In recent decades, we have observed an exponential growth in seismic activity and anomalous behavior in magmatic and volcanic processes, as well as atypical behavior of the Earth's magnetic field. We are also witnessing an increase in deep focus earthquakes, which are presumably associated with colossal explosions within the mantle. Regarding seismicity, let us take a closer look at seismic activity. Unfortunately, a trend that has not received sufficient attention is the consistent exponential growth of seismic activity. In recent years, we have observed a steady increase in daily events of magnitude 5. They are becoming commonplace. However, in the last 6 months, the planet has reached a level of consistent magnitude 6. If we continue moving toward regular earthquakes of magnitude 7, the consequences could become catastrophic. It is noteworthy that we previously believed earthquakes of magnitude 5 were impossible at great depths in the mantle. However, magnitudes of 7 are now regularly being recorded at depths exceeding 600 kilometers. The current trend of increasing intensity of deep focus earthquakes is a phenomenon that raises serious concerns, as it indicates the accumulation of a vast amount of energy within the Earth's interior. This raises a question regarding the source of this colossal amount of energy released during these events. Moreover, changes are being observed in the composition of lava from erupting volcanoes, which indicates rising temperatures within the Earth's interior. These changes suggest that temperatures are not decreasing, which demands serious analysis from us. And regarding cyclicity, modern science allows us to reconstruct Earth's history by studying ancient layers of ice, known as ice cores, as well as sediment deposits, fossils, and various soil layers. This extensive material serves as a chronicle of our planet, providing valuable records of how the climate has changed over millennia. Thanks to these studies, scientists have discovered that the changes we are observing today, a sharp rise in temperatures, melting glaciers, increased volcanic activity, a growth in the number and intensity of earthquakes, and the drift of the magnetic pole and the weakening of magnetic field, already occurred before around 12,000 years ago. How do we know about these events? They left behind a layer of destruction known as the Uslo horizon, This layer of soot and charcoal ranging from 5 to 15 centimeters thick has been found across 10 countries on 4 continents. This so-called black mat separates the Pleistocene from the Holocene and contains evidence of massive abrupt cataclysms that occurred at that time. Interestingly enough, beneath this layer, remnants of extinct megafauna have been found. However, above it, such remains are rare, indicating a mass extinction resulting from these global changes. Geological studies have shown that this layer of black mats formed during the eruption of the ALLATRA sea volcano in Germany, whose ash spread across Europe. Scientists associate this layer with a gigantic forest fire caused by volcanic eruptions. A similar layer of coal and ash was found in North America and was named the Clovis Horizon. This carbon-rich black layer, dated to 12.9 thousand years ago, was discovered at 50 Clovis-era sites and coincides with the abrupt cooling of the Younger Dryas, which began after an equally abrupt warming. It is equally important to mention that the findings of the frozen mammoths on the northern slopes of Siberia confirm catastrophic floods and abrupt cooling 12,000 years ago. Some researchers have suggested that the cause of the catastrophe might have been a meteorite impact. However, a more in-depth analysis of the microelement composition in the ash layers pointed to volcanic activity as the primary source. In recent studies conducted by American and Spanish scientists, 3 gigantic deposits from supervolcano eruptions were discovered on the floor of the Mediterranean Sea, indicating a cyclicity of these catastrophic events in Europe with an interval of 10 to 15,000 years. Thus we observe the cyclical activation of supervolcanoes, which resembles the workings of a clock's mechanism. 12,500 years ago, the eruption of the Flagrant Fields supervolcano occurred off the coast of Italy. And 24 to 25,000 years ago, the Taupo volcano erupted in New Zealand. Each of these global catastrophes led to mass extinctions and changes in ecosystems. Research based on the geochronology of quaternary deposits, analysis of ice cores, bottom sediments, and paleosoils, lava flows, ash layers, geomorphology of supervolcanoes, and paleomagnetic data shows that there likely exists a certain cyclicity of geodynamic activation with an approximate repetition period of every 12,000 years. It should be noted that hypotheses about cycles of abrupt climatic and geodynamic changes have been proposed independently at different times by scientists and researchers from various countries around the entire world. The study of volcanic cycles has revealed an interesting pattern. Volcanic eruptions occur every 12,000 years, but every second eruption cycle, that is every 24,000 years, turns out to be significantly more potent than the previous cycle. For example, 72 to 74,000 years ago, the catastrophic eruption of the Toba volcano took place, during which the population decreased to 10,000 people, according to some estimates. The last major activation of geodynamic processes occurred approximately 12,000 years ago. And 24,000 years ago, it was significantly more intense. These data compel us to consider that the changes in the climate exacerbated by human activity may only be the beginning of even more severe and large-scale events that humanity will have to face. Thus, the need for serious attention to not only climate change, but also Earth's geodynamics is increasing, along with the necessity of integrating knowledge about our planet's past to better understand the abnormal processes occurring today. The question of the colossal energy driving such powerful geodynamic events remains unresolved. It requires an interdisciplinary approach for complete comprehension. There are additional facts that may point to the astronomical nature of this cycle. Let us draw attention to the fact that in recent years, significant changes in climatic conditions and geological processes have been observed on other planets of our solar system. Increases in the wind speeds and hurricane sizes have been recorded on Uranus, Jupiter, and Venus. At the same time, Mars is experiencing the melting of polar ice caps, and volcanic activity on Venus and Mars continues to grow. Furthermore, earthquakes on Mars are intensifying, indicating that emergence of anomalous geodynamic activity. Unprecedented phenomena occurring on other planets of our solar system indicate a sharp increase in seismic and volcanic activity, even on bodies were previously considered dead. We cannot ignore that this is a unifying process, and it is time to stop remaining silent about it. We need collaboration among various scientific disciplines so that we can delve deeper into the mechanisms underlying the climatic and geodynamic changes we observe today, both on Earth and in other planets of the solar system. These changes may be part of a broader cosmic processes. Let me now address the anthropogenic factor. Even more worrisome is the fact that this time natural geodynamic activity is superimposed on anthropogenic human activity, which has led to a serious deterioration of the climatic situation. Emissions of greenhouse gases undoubtedly represent a significant factor and may possibly play a decisive role. However, despite the fact that our planet has endured cycles of catastrophes over millions of years, we may find it much more difficult to overcome the current cycle due to the exacerbation by anthropogenic factors. Historically, the ocean has played a crucial role in mitigating the consequences of these cataclysms, acting as a natural mechanism for dissipating heat from the Earth's interior. In this regard, human activity has significantly altered this process. Human-made plastics have been introduced into the ocean, as well as hydrocarbons from oil spills. Now, instead of cooling, the ocean has begun to capture and retain heat, causing our oceans to heat up. Historical data obtained from the study of coral reefs show that in previous cycles, the ocean successfully released heat. In contrast, now the reefs are dying from overheating. Unfortunately, the increase in anomalies is outpacing our most optimistic estimates concerning the remaining time for action. Alas, let's now discuss the most important issue, a solution to our problem. Those who asserted that global changes would occur in 150 years or more now admit that they were mistaken. They are seeking explanations for their error and acknowledge that the progression of the changes is happening faster than anticipated. My colleagues, the macroeconomic consequences of climate change could prove catastrophic. If this trend continues, in a few years we will simply not have enough global GDP to restore what has been destroyed, let alone support individual countries. The global economy directly depends on the climate, and its changes are already leading to the migration of millions of people. Financial losses will dramatically increase in all countries worldwide, and from an economic standpoint, the situation looks exceptionally bleak. Everyone recognizes that the climate is changing, and finding a solution to this threat is a top priority. Unfortunately, at present, geopolitical and macroeconomic issues dominate the climate agenda, whereas the priorities should be reversed. We must act now before the situation reaches critical levels. If the level of seismic activity reaches magnitude 7 with the same frequency that magnitude 5s are currently being recorded, it could render solving the problem wholly irrelevant. No matter how we define causes of climate change, regardless of the approach, the most important thing is to find solutions capable of helping humanity. We need to put an end to the pessimistic attitudes that unfortunately prevail among scientists and experts studying the climate. However, this pessimism is undoubtedly understandable when we consider the progressing changes not only on Earth but also on other planets of the solar system. Until we determine all the causes of geodynamic and climatic anomalies, we will not be able to find effective solutions. There are already theories and developments that demonstrate a positive impact on the environment. We continue to evolve and seek new solutions. Unfortunately, this is not enough. To achieve significant results, an interdisciplinary approach is required, one that unites the efforts of specialists at a global level. This is not just desirable, it is vital. I call upon the reason and common sense of all people in light of the current challenges facing humanity. Geopolitical and microeconomic issues, though important, should not eclipse the critical significance of climate change. We must set aside the political and economic disputes that divide us and focus on the climate agenda, which should become an absolute imperative. We are confronting such a global problem for the first time. It is time for interagency, intersectoral, and interdisciplinary analysis of the situation. We need courageous people, bold leaders ready to embark upon this critical initiative because our shared future depends on it. There is but one imposing question which demands attention. Who will take on this initiative? We need to create a platform for consultations and international disciplinary dialogue. This will allow specialists to start gathering and discussing the escalating threats. A venue is required for free interdisciplinary discussions where scientists can exchange ideas without external pressure. Every theory is important and requires discussion because only through free thinking will we find innovative solutions. The longer we postpone action, the more catastrophic the consequences will be. This is already evident to any rational person. It is paramount that the scientific community does not limit itself to observation but actively strive to predict and solve the problem. We really should be thinking about how we can prevent further disaster escalations rather than just recording statistics. At this critical moment, we must unite the efforts of all who are concerned about climate issues, from physicists to meteorologists. Adaptation measures that once seemed possible no longer work. Destroyed buildings can be rebuilt, but lost lives cannot be repatriated. Even if the situation seems more stable in some regions, this does not mean they will remain unaffected. Our world is very fragile, and only by uniting our efforts can we actually prevent the pending catastrophe. In closing, I feel compelled from my scientific perspective to emphasize this one crucial point. Nature has endowed humanity with the gift of intellect. At this critical juncture, more than ever before, it is imperative that you, as a people, harness this invaluable gift. All that remains is for you to summon the courage to direct your intellect toward the greater good.